Okay, good evening and welcome to today's session. Yeah, we are continuing on index clustering. We're going to do a lab today just to implement, all what we talked about on Tuesday. So, just pop quiz. Let's just remind ourselves before we jump in. What is an index cluster? What do we mean when we say we're having an index cluster?
Indexers that replicate data.
Right. Connecting the indexes together so it is replicated, right? Okay. And then, so that would lead us to what are some of the benefits of index clustering?
Recovery, fidelity.
Yep.
High availability of data, like having a lot of data available to you whenever you want.
Right. Yeah. Any other?
Disaster recovery.
Right. And how can you elaborate on that? How does index cluster helps disaster recovery?
So it can tolerate the failure of a data center.
Yeah, and that's because the data is replicated to other data centers, right? So we can still continue even if we lose a whole data center. Good. And that is when we have multi-site clustering and all of that. Okay. So what is the requirement to have an indexer cluster? How many indexers do we need to have a cluster?
More than one.
Right. More than one. Okay. And when we talk about indexer clustering, then we have to introduce a new management instance. What is that?
The cluster manager.
Yeah, cluster manager. And what does the cluster manager do?
It tells the indexes how to replicate the data, and then it's also it manages the affairs of the indexes basically.
Yep.
It deploys configuration to the indexes and manage failover and buckets like recovery and stuff like that.
Right. Right. Okay. All right. So so the cluster manager does all that, manages the affairs of the cluster. And so if in an indexer cluster, what is the operating system requirement?
It has to be the same version as the indexer or higher.
So we're talking about the indexers first. So all the instances in the cluster, what is so we have, I'm talking about requirement with regards to OS, and we have the specs regards to OS and the version of Splunk. So I was asking with regards to OS, what is the requirement?
Yeah, Linux has to be for Linux and Windows for Windows.
Yeah, you cannot mix them, right? They have to be identical. So that's what I'm looking for. They have to be completely identical. So the same specs, same storage, same everything. Okay, and that means same OS. The indexers have to be of the same version. The cluster manager can be of a different version, right? Can be of a higher version or same. It cannot be a lower one. The indexers cannot be 9 9.1 and the cluster manager be 9.0. It can happen the reverse, but not the other way. Okay, all right. Okay, seems like we have a grip on what we, so okay, what is the replication factor? What is the replication factor?
It specifies how many total copies of raw data the index the cluster should maintain.
Right. Great. Yep. How about the search factor?
It also specifies how how many copies are searchable.
How many copies of the raw data should be searchable at any point in time? Okay, great. Well, we'll jump into it. Like I said, we're going to do a lab on just all this concept to see how everything just fit in together. And also, we're going to have a cluster of 3 indexers and a search head. And we know we would need a machine dedicated to manage the indexers, and would have a cluster manager. And also we would just try to test, sending data to the indexers. So we would have, we'll create a forwarder here. Anybody can maybe launch a forwarder and try to connect to my cluster and see. You're welcome to do that. But I would have a single forwarder and we'll see how we can manage the cluster. So first of all, in creating my cluster, in enabling my cluster, which component should I start with? Which of the components?
Indexer.
Sorry?
The indexer.
Why?
You have to make the indexer ready so that when data is sent, it should be there to receive the data so that it won't get lost.
Right. So that is in general when you are setting up your Splunk environment. Yes. So the indexing tier, that aspect have to be ready before you go to any other one. But here we're going specifically now. We know we're dealing with indexers, but we're dealing with indexers in a cluster. So when we are talking about a cluster of indexers, we're trying to enable that. What component should we launch and enable first?
Is it the cluster master?
Cluster master.
Right, cluster master, right? Or cluster manager, because we have to, launch that and make sure it is ready. And then when we're launching the indexers, we then point them to the cluster manager, right? So we need that. So I would be using our scripts that we build here to do this, because we don't want to repeat. Why do we have a script if we have to do it manually? So one thing that I wanted to introduce today, just for you to get a feel of that, we've been using, since we started the class, we've been just using the defaults of Splunk. So for example, where the data is stored. So normally we just use what Splunk gives us. And in that way, what Splunk is doing is storing the data inside of the application Splunk. And I told you guys that you can, that's not, most of the time, it's 90% of the time, that's not the case. So they would have a mount point, or you can call it a drive somewhere, a storage capacity somewhere where the data would be stored outside of Splunk. So that is again just a way to just fault tolerance. So if something happens to Splunk, the application goes down, it does not go with the data. You still have your data. You can go and initialize and configure another instance and still connect it to your data. So that's why mostly people change that. They do not leave it as the default. So that's why in my script here, you can see I added this line here. So we are creating a directory as part of the script. We're going to create a directory in OPT. We'll call it Splunk data. We'll call that directory Splunk data, and then go through the steps in installing Splunk. The same, and when we give access to Splunk the user, to Splunk the application, the same, the directory that we've created, we're going to give that, make the Splunk user the owner of that directory as well, Splunk data, because what the intention is, our data will be sent to this directory, not the local. Do we remember the local or the default location where the data goes? Anybody remembers that?
Valid.
Splunk.
Right, Valib Splunk. So that is the default location. We are going to change that. So we will tell Splunk, we have to go tell Splunk that you do not send data to that location. This is where we want our data. So we're going to make that happen. And so all the other things are, I mean, you know how to do this now. If it's indexers, enable listen. You know, if it's not, so I can comment that if I don't need it. And, you know, if it's a forwarder, connected to the indexers, you know, and also set the host name. So other things I have added here. Again, we know this part. I mean, make it a deployment client, that part we know. But we saw on the last class how to, you know, set up the indexer cluster. We say we start with the enabling the cluster manager. And that's what we've said here, that we're going to first enable the cluster manager. And then we can enable the peers or the indexers in the cluster. And then we can enable the searcher as well. So you saw that we can use a script to do it. Sorry, we can use I didn't want to say a script. We can use the CLI to do it. We can run a command via command line. We can edit the configuration file, or we can do it via Splunk Web. So all those are valid ways of doing it. So since I am using a script, I will just opt for the command line option, especially to do to enable the cluster manager. So that's why I'm just going to enable this. So we're enabling the cluster manager. We know that is the command, opt Splunk, edit cluster config. The mode is manager. Replication factor, we are going for 2 because we have 3 indexers in the cluster. So I'm just setting it for 2. Search factor is 1, and then secret. So mostly they would advise the best practice for Splunk is make this 3 and then the search factor 2. But I mean, I'll just keep it as simple as this. And then we have our key, our cluster label, and all that. And then that will be authenticated. So that's what I'm adding here. The only thing I wanted to point out is we're having a directory created, and we would direct Splunk to send the data there. Any questions on the script? We would now.
How many instances are you creating?
So my cluster would have 3 indexers. So that means I need 3 indexers, 1 cluster manager, 1 search head at least, and then the forwarders that would send the data. So we'll start with the cluster manager. So let me see first. Did I name it correctly?
Okay, so you're gonna do the cluster manager by yourself.
Yes. So remember, I mean, you have to enable the cluster manager first, because you are, when you provision the indexers, you are telling them to join the cluster. So we have to do the cluster manager first. So I'll do CM here. And copy that and go through the steps of just creating that instance. So I'll just say Sadija CM. You can follow along if you want.
Can you drop that script for the cluster manager?
Okay. You know, I don't like to share my script. You know that, right? I don't want you to be lazy. I don't want to. What I want you to do is try to, you have a forwarder script already, just build a forwarder and connect to it. Just try to pay attention so that you can, okay, well done here. Okay, let's make this 15. And I will paste our thing. So try to build a forwarder and just connect that to the indexers that would have. All right, so we have this, we have the script. This is a single instance, so let's create that. Make sure it's good here. Okay, yep. All right, so that is being created. I'll go back there and it's try to edit the script here now and do for indexer. So now I want to launch my indexers. So we'll close that, enable the PS. So just enable that. We'll get the, so the IP address for my cluster manager, copy that, update that on the script here. Right. And I will create our indexers, call this. So IDX. Right. IDX 0. Right, I want 3 instances of that. And which one is 2? All right, that is being created. We'll do our search head. And here now just say then comment that as well. Okay, do you guys are you following what we're doing here? Just the steps as we did on the presentation the last time. Are you guys with me?
Yes.
Okay. Let's call that one. Okay, we'll have a single search head. I copy this. Right. Yeah, so we're getting ready there. So let's see if our cluster manager is ready. Okay, it's taking its time. While we wait for that, we can create our the forwarder. So for the forwarder, I have the indexers 1, 2, and 3. So just copy the IPs. I'll just do it manually here again just to send the IPs. So you see there what we did is just connect to the indexer. So I just did because I have 3 indexers, so I have 3 of the commands there. So we'll copy the IPs of all my indexers. Right, and everything else should look good here. We didn't do any much changes. So copy that. All right. This is ready still. Yeah, just giving it a little bit time there. Okay, so while that is loading, give me one moment. I just need to grab water here quick. One moment. All right, guys, are you still there? I think cluster manager is ready. Are you with me?
Yes.
Yep.
Okay. Okay, so I mean, when we log into the cluster manager, the first thing I want to do is just validate that this instance was enabled, the machine was enabled as a cluster manager. If we go to settings, you see there is a dashboard as we did or as we had for forwarder management, which was for the deployment server, right? You guys remember? We have a dashboard for indexer clustering as well. So if I click on that, you see right there, it shows me that this is ready. So it says indexer clustering, this is the manager node. And it says right now, search heads, that's the manager. So the cluster manager itself, the Splunk sees it as a search head. That's just how Splunk is set up. Because anything else that is not so you would say it's anything else that is not an indexer for the setup for the deployment, apart from a forwarder. Forwarders are labeled as forwarders, but everything else is seen as a search head. So that's why in the cluster, on the search heads, you see the cluster manager there. It does not mean that this is executing any searches or anything, but it's just seen as a search head. So right now, the indexers are getting ready. It takes a little bit for them to spin up everything and join the cluster. So that's why it tells you that. If we go to messages, it says waiting for a requisite number of peers to join. So it is waiting. When they are ready, they will join the cluster and they will see how the dashboard looks. And just while we wait for that, if I go to edit here, and you just see here, it says node type, manager node configuration. So if I go to that, it shows me if this was not configured, right? If I had not configured this machine yet, if I come to this like dashboard, if I go to settings and the indexer clustering, it would not show me this page. You know how we did when we were doing the deployment server. When you go to it, it will tell you enable clustering. You would have the option like here, and you can click on it and it enables it, or you can go there, edit. You will not have this option because it's not enabled. So you'll see an option here that says enable clustering, click on it, and the option will be to, manage. It will show you the different options. Right now, we've configured this instance to serve as a manager. So it's already manager node. It shows you the replication factor we set, the search factor, that's the pass4 SIM key, that secret key that we set, and the cluster label. So you see that there, everything is set correctly. And you can see the indexers are starting to join. So one of them, if I go to peers right now under peers, it says one of them is here. It says, and you see right away, it starts showing you a status of the cluster. Some data is not searchable. You see the error there, the sign there, it says one searchable. And so search factor is not met, replication factor is not met. And that's because we need at least 2 indexers in the cluster for us to be able to meet the search factor. So we only have 1 right now. So definitely there's no way, it's impossible to meet that. So eventually when we have the next indexer join, you would see this turn green. So that's why this page is really important. You come here and see the status of your cluster. You see if it's, if you have any errors and anything, you will see them here. So it's still updating. Eventually we'll see them here, and as they join, you see this turn green. All right, any questions?
Aido, the name of the cluster, was that in your script, or does it automatically populate a name for
that cluster
the
one? Yeah, it is on the script. So if we go there, if I go to that script, on the command I ran there to enable the cluster manager. So you see it says after here it says dash cluster label, and it says cluster 1. So it is there.
Okay.
Yeah.
Thank you.
Mhm. So they're still coming. And right away, if I go to, so on the cluster manager, so we have peers. This is for all the indexers in the cluster. Indexes, this tab is for the indexes that exist. I mean, the indexes that exist in the cluster. You know, inside of the indexer, we have indexes. And you guys know already of the default indexes that exist: underscore internal, underscore audit, introspection, all those indexes. So you would see the list of indexes here, if they're replicated or not. Here we have search heads. Search heads now would show, because we joined, we created a search head. We created an instance that we called search head, and we ran a command to join it to the cluster. So that's what we're seeing here. So on the search heads, it shows you how many search heads are connected to this cluster, and they're able to search. Like I tell you, the cluster manager would show up as a search head. It does not necessarily mean that it will be able to search data on the indexers. It's just seen as that. And you see the search head. You can see that is the GUID. If we go back to the indexers, you know, it's taken long for them to come there. But if you see, that is the indexer. If I drop down on it, tells you the location, the IP of the indexer and the port, everything, replication port, as it is set. If you see in the script, in the command that we run, you would see that enable peer. So we say edit, cluster config, mode is peer, management URI, that is the manager, we have to point it, replication port 9887, and then secret. So that's what you're seeing here. So replication port, that's what we said, base generation ID, GUID. This is how the indexer is identified. This GUID is what is used to identify the indexer on the cluster. So when a bucket hits this indexer first, and we know this indexer will be the origin of that bucket, right? That data, this here will be the origin. So that bucket would have this GUID as part of the name. So whenever it is replicated to other indexes or indexers, then they would know that the origin, the owner of this bucket is indexer 1 or whatever we call it in this the name there. So that's how they identify that the origin of this data is from this indexer, because all of them would have that. So this GUID is important. So that's the difference. In I will show you that when the buckets are created and everything, we'll go see. But in regular indexers that are not in clusters, they would not, the bucket's name would not have the GUID. It would just, I mean, because it does not have to replicate it anywhere. So the bucket lives inside of the indexer, and that's good. But here, because they have to share data among themselves, they have to be able to identify that this is from here, this is who owns this. So it's easy to promote and do all that. Are you taking too long? Okay, let's just give it a little bit. We'll try. If it doesn't come up, we'll try to go access those machines and see why they're taking this long to join. This HPA has the following message index not ready. Yep. Yep, it's not ready because it's we can meet the replication factor. if one indexer is able to join, the other should be able as well. If there is an issue with the scripts, all of them should not be able to join. So this could just be some network issue or something that Splunk is just taking long to recognize. Let's start. I mean, eventually we should log into all these machines. So let's start with the cluster manager here. Let's see. Let's SSH into that. Then let's do the indexers. Okay, so let's see. Let's see this machine. Mm. So Splunk is running here. Default host name. Okay, so this is the 2259. This is the one that we are seeing. Yeah, okay, so let's see the other ones if we can access them. Says running. CD2. We know server.conf is what is responsible for to create the cluster. Let's just cut the server.conf. So inside of the server.conf, let's see what happened here. So instead of server.conf, that's the server name. We know that's the name there. You see, for some reason, the cluster instance that did not show up. So let's compare. You see here, we're not seeing that cluster instance. So let's check this one. I don't know what Splunk did there. So CD2. Can you even cut it from here? server.conf. So you see right here, it has the replication port and everything, clustering, and it did that. So it has the key, it hashed the key. So for some reason, I don't know if the script just failed at some point. It did not do the other ones, so we don't, that's why we're not seeing them. So we have to manually just either run the command, or let's just do that. Let's just run the command on them. Okay, so this is even good. So we'll see how we can run the command. One of them I'll run the command, the other one I will go to the web, log in on the web of the server, and make it join the cluster that way. Well, let's run the command on this one. I can go to the script and see. So the script, so there is the script to say opt Splunk. Are you guys following? If I mean anything you're confused, let me know, please. So I'm doing it a manual here just to see. It just shows you that it does not happen always as you intended to. So let's restart. So that's 2. So what I'll do is for 3, for index at 3, I'll just, because it's a full instance of Splunk, I'll just access the web on it. Now, if I go to again to validate, I go here and go to index at clustering. You see, it is not part of the cluster. For some reason, the script just ran on one machine and did not enable the other ones. So you see, this is what I was saying. See, index at clustering, enable clustering. So I select that. It has the different options. This is even better for us. I wanted you guys to see how it is done. That's why it didn't work. So if I wanted this instance to be a manager, select that, go next, peer, search it. So all the options are here. We know this should be a peer. So go next, and then now we have to supply the manager URI, which is that IP there. So copy that. Mm-hmm. '8089, which is the management port. Replication port, make sure you use the same port. The port that we used on the script is this one. Setup port is 9887. So make sure they have to have the same port. If not, you'll not be able to replicate the data. And then the passport SIM key. So I know my passport SIM key is the same as my Splunk login, my Splunk login. So I'll just select that and then enable peer node. So don't want that. So you see, it says I need to restart the same message I got when I ran the CLI, the command via CLI. So I'll restart this machine. We'll join the cluster as well. So let's see. So the first instance I did has just joined the cluster. So you see now we have 2 machines, and right away it says all data is searchable, search factor is met, replication factor is met, because we just need 2 machines to be able to meet the replication and search factor here. So it is met. We have we would have 3 machines at the end of the day, but we just needed 2. Yes, sir, Benjamin.
Yeah, Seidu, the port number for the this index is the replication, and is it something that you can choose by yourself, or there is like the way we have the other port numbers that you need to, because I see that some are using 9100 and others are 8080, but you used
So every port, every Splunk port is customizable. You have the option to change it. 9997 is not a must. So Splunk has those as just saying you should have a port here, and this is for us. This is what the default one we've been using. If for any reason in your environment 9997 is being used by another process, another application, then you cannot share that. So you remember, you cannot use the same port for two things on the same machine, right? So if that's the case, you can set another port. So 9997, you can set your data port to a different one. You just need to know that it is by default 9997. The 8089 management port, that is again just default. That's why you are telling it. Splunk is telling you is default, but the reason why they give you the option to state it is because you can change it. So if you just had to run here and do not state it, that's when it will be set for you. But you have the option to set whatever port you want. Same for replication port. Whatever port that is available for you, just know that you have to make sure you give access on that port. As long as the port is available, you can use it. So now we see all three indexers are in the cluster, and if we drop down on them here, you see all of them, you see their locations, they all have different GUIDs. All of them have different GUIDs. So this is really vital for you. This is how they are differentiated. So any bucket that originates from this indexer would have that GUID to say this is where you originate. The same thing for this indexer and this indexer. So when they replicate buckets among each other, they know that this is where the bucket came from and all of that. So any questions there, or did I answer your question?
Yeah, thank you.
Yep. So this was good for us to to do, because I opted to just run the script, and we've seen now how you can do it other ways apart from the script. So this is good. So now we have our indexer. It looks like the cluster is ready. So we can see that we have the peers, the three peers, we have the indexes, and there should be where the sachets. So yeah, the sachets, we have the two sachets. So let's now connect, let's SSH into the sachet, because let's just access the sachet on the web, because we know the sachet is where we can search for the data. So I'll just log into that machine. I'll just use this. I don't need that on the web anymore. Okay, that is my sachet. So wait, let's make sure. Okay. 13126. Okay. Okay. Save that. So just on the sachet again, if I go there and go to indexer clustering, you see that now, because it has joined the cluster, it says cluster sachet. It is a sachet that is the manager URI that is connecting to, and everything, it says everything is met. So you see that. So it's always good to validate. If I go back to my apps now and just search here. So index equals internal, just to see what we have seen here. Let's do last 15 minutes. Okay, if we look at here, we see all three indexers and then the sachet. So we see that. So that's good. Is this our full environment? We do have a forwarder. We have a forwarder, right? So why aren't we seeing our forwarder? Why is the forwarder not showing up?
The forwarder is not a part of the cluster.
Yes, but this is not the cluster. This is the sachet. Remember, this is where we see everything that is sending data to the indexers. So on our sachet, when we look for on the underscore internal, we should see every instance that is sending data to the indexers. Right now, we see all three indexers and the sachet.
Have we done file server?
Right.
So,
Well, yeah, we did that for the forwarder. So we did add forward server. We set all the indexers. We did that. Why would we did that, but we're not seeing the forwarder here? What could be the problem? Ideas, troubleshooting.
let's check the time maybe. If
Time?
no, yep, if no data has come in the last 15 minutes, maybe.
Yep, no, last 15 minutes, nothing. See system, just that. So remember, one of the steps in your Splunk deployment is you create your indexer, you enable listen on the indexer, and then tell the forwarder to send data. If I go to my script here, on the script, I did not intentionally, I did not enable listen. So remember, we use this script to create our indexers, and I did not enable listen on the indexer. Intentionally did that because we want to create that configuration and deploy it via the cluster manager. So right now, the forwarder is trying to send data, but there is no location to send it to because the port is not open to, it's not, indexers are not listening on that port. So we have to now configure that. So we'll do that, configure that, and then also configure indexes. So create indexes and then create that configuration and add it there. So we know already, if I come here, we know the output.conf, right? That we normally deploy. This output.conf, we're familiar with this on how, we deploy it. That is already set on our forwarders, right? We know that it's set there. We could have, I did not repeat this because we know already how to configure that and deploy it via deployment server. So that's why I did just the CLI method. On the indexer, input.conf, if we run the command to enable listen, this is what it would enable for us, Splunk TCP 9997. So we have to deploy this configuration in our input.conf file to the indexers. We can also even deploy this that disable the web browser, web server, so that we can access the indexers on the web. That's good. Deploy all of this, and also deploy indexes. So indexes to the indexer. So let's do that. So we're going to, if I go to my cluster manager, so remember, we want to do everything from the cluster manager. We want whatever configurations that are on the indexers, we want everything to be identical, right? So do we remember where do I create the configurations that I would push to these indexers in the cluster manager? Do we remember from the last class? So here is
Is it the cluster management?
Master apps.
Yeah.
Yeah, Etsy manager app.
Yeah, manager apps or master apps, correct? So if I cd to okay, this Splunk, Etsy. So let's just go to Etsy right now and just show you that we have both in there, LL. So we have down here, we have manager apps and we have master apps. So Splunk is still maintaining both directories, both you can put the configuration in either of them, they would work. Eventually, master apps would go away. So if, start making use of the manager app. So we'll go to manager app and create the configuration there. Manager apps, inside of manager apps, we have, remember, I told you guys, we have the underscore cluster directory that is already there. If you are pushing just a single configuration file, like just a file, you can just put it inside of this. This is an app that is built for you already. If you're trying to push configurations that is specific to like maybe a data source, you want to package it in an app, you can create your own app inside of this manager app and put it there. So here, we just want to send, configuration files. We need input.conf, web.conf, and indexes.conf. So we'll just put it under here. We'll just put it under here for now. So if I can cd to underscore cluster, and then in there, it should have local and default. So let's cd to local. So if we pwd here, we see that's the location we are at, and there should be nothing inside of there. It's just the README. So I want to create those configurations. So if we look at it here, let's start first. We need the web.conf. Let's create that. So in here, VI. So web.conf. Okay, this is disabling the web browser for the indexers. Okay, and I can cut that. Okay, that is good. The next one is input.conf to enable listings. So again, vi.conf. Right, copy that. Okay. Again, cat input. We have that there. The last one now is indexes.conf because we want to deploy some indexes to the indexers that we have. So vi indexes.conf. So in here, so if I come to my indexes now, just to point out that I added some things here. Remember, we said we have to inform, we have to tell Splunk, tell the indexers that we are sending the data to a different location than the default they have. So first of all, because this is a cluster, because this is an indexer cluster, so I am saying I have a default stanza, and default stanza would apply to any index that lives inside of this indexes.conf. I'm saying rep factor is auto. So whatever I set for the rep factor should be applied on all the indexes that are created here. So we set that to auto. You want to set that for, any cluster. If you're working on just individual indexers, then you don't need that. But if you're doing a cluster, then we need that. So this other stanza here, where we say volume and then set the volume. So it can be anything. I say volume primary, I can say volume data, whatever. But volume and then set the volume. So inside of the stanza and then say path. Now here I tell it the volume. So my directory that I created, remember on the script, I told you guys that we need to create this directory that is Splunk data. So that is the directory we are referencing here now. I'm saying my data should be sent to this path, OPT Splunk data. So I'm telling Splunk that whatever indexes that are created should live in that location. And I'm just saying this is the size of the index, max the data size in megabytes, that is that, and then create my indexes. So you see the difference here now is I have to, if I want any data to go to that volume that I've created inside of my path, I have to replace the, originally for third part here, we had this where it says Splunk DB, and then the name of the index, and then the database where it is going. Now for the first two, the home and cold part, because we want that data outside of the default Splunk location, we have to tell it that this location that I have specified here, which has the path, that's where I want you to send the data. So it's a volume primary, the name of my index, DB. Same thing for the cold path, say that. So that's what I'm doing for both the Windows index and also the Linux index. Right now, what I'm doing here is I am leaving all the default indexes. Remember, default indexes are the main, the main index, the underscore internal, underscore audit, all of those are default indexes. I have not changed them. Those will still go to the Splunk, location itself. So I can change those. Again, this class is more fundamental. So this is entry level. We have even deep dive into configuring, Splunk. Splunk has identical, or they have configurations that they have created that they expect every Splunk customer would start from. So they have apps. For example, like if you're creating an index, a cluster, what configurations would go to the cluster manager that would enable it to be a cluster manager. They have those settings. All you need to do is enable what you need and leave what you want. Like an app that would create indexes on the indexers that you can deploy via the cluster manager. Remember, we said you can either create package whatever configurations in an app, or you can just put the configuration file on the underscore cluster, which is what we're doing here. So they have apps. We can do that as one of maybe the bonus topics later. I'll teach you guys what is Splunk is called base configs. So they have these configs, they live out there, they created them. They would advise a customer to download those configurations and edit them appropriately and just use those. In that way, if you have an issue, because at some point you would need Splunk support to troubleshoot some issues, or like if like an engineer is working here and they leave, another one comes. If you are using Splunk best practice, then it will be easy for someone to just come and be able to take over from the last person and understand what is there, because they know that this is what Splunk expects. So an example of that, let me see if I can pull up one of the apps here. Yeah, that's one thing. Do you see this screen?
Yes.
Okay, so let's see. One thing that it does not, because I'm sharing that, it does not show. So let me do this quick. Are you guys still seeing my screen?
Yes.
Okay, so let's do this. Wait, let me. Pull up this. So you see my desktop right now, right? So you see this. Do you see this?
No.
Okay, so what do you say right now? Okay, maybe I need to stop the share. So do you see this screen now?
Yeah.
Okay. So what I was saying, inside of desktop here, if I open this right there, you go to I have base configs. So Splunk, so I have these configurations for index replications. So if I open that, you would see under there, we have Splunk has a naming convention that they will give. So it will be the organization, the function, so org, cluster, forwarder, output. So if you are doing an indexer cluster and you want to, deploy an output.conf app, so that's the app. You can just open it. If I drop down on it, you see that it has, local, it has an output.conf, and this output.conf is okay, that's not the content of that. Let's go back to it. So output.conf, let's open it with this. Okay, something is just corrupted right now here. Okay, all right, yeah, so output.conf, let's open that. So that output.conf, the same settings, the same things that we would see in our output.conf. So enable TCP out, your indexers, the servers. So, and he would even explain to you that, okay, this is the meaning of this and everything. So they have these apps created already that they will share to customers. All you need to do is now, for example, if you are enabling this TCP out your indexers, you just come and replace this with your servers. So server 1, the IP address of your server, server 2 at 9997, enable that, deploy it. So these are called base configs, Splunk base configs. We will do this as one of the additional classes, and I'll just go through and teach you that. You see, cluster indexer base. So this, if I wanted to create an indexer, put it in a cluster, I would, deploy this app there. What Splunk is trying to identify here, that don't put anything in system local. Remember, I explained to you guys the idea of system local app, the system directory, the app, and the users, all the precedence of when configuration is in system local versus app and all of that. So they're saying to easily manage configurations, just keep them in apps. So create apps, deploy them to Etsy apps so that you can easily change, deploy new configurations and edit those. Because if we have them in system local, you're not able to manage those by any management instance. So you can only, go manually to the machine and manage it. So I can come here, indexes.conf, open indexes.conf just to show you basic things here. Inside of that, because this is a cluster, you see what I showed you there, that ref factor, it says that is auto, and it just gives you basic things here. For them, they even went and segregated a lot of things. So inside of, we have multiple indexes.conf with just basic configurations. But what I want to show you here is if I go to just the base configs, so this is for index replication, right? If I go to index replication, code data. So here, okay, so we have base configs here. So I have all indexes. So inside of all indexes here, I have indexes.conf. So let's open this. So if I open this just to show you, so here again, you would see they explain everything that you can set. And you would see that right now everything is commented. So it's not like when you are using this base config, like it would destroy your environment. You would look at it and see what you need to change, what you need to enable. If we need to enable a setting, we just uncomment it. But if you scroll down here, it tells you what is the volume settings, what a volume setting is. Example, you can read on that. So volume 1 tells you volume primary, how you can set that. The default right now is valid Splunk. You can change it to whatever. So that's what I just used and change it to OPT Splunk data. You can have a secondary volume, volume home and all of that. And now you can also your default indexes. Remember, we have the default indexes, main, history, all this summary underscore internal. You can also set those to be sent to the directory where your data is. In our case right now, we're just sending our custom indexes. So you see here, we have said, for example, we are using volume primary and we set the path to that. And now inside of here, main, so you're setting again home, volume primary, the name of the index. For the same for history, you set all of that, summary. So we're saying all the data, any data that is generated, we don't want it to live inside of Splunk. Send it to whatever location we set. So you can set that. I just wanted to show you that you can set that for even the internal indexes. For our case right now, we're not doing that. You see, these will be given to you because they know these are the internal indexes that exist. If you see down here, it says custom indexes. So if I wanted to create my, like the Linux index, the Windows index, I'll come down here now and add that, copy and paste that. So that will be the custom index. These are all default indexes. They're just, the only difference they're showing here is you have to send it to a different location than the default. So we can have an additional bonus class where I will teach you, this would use all base configs to deploy, our Splunk environment. You would see how that fancy and everything. We can use that on the deployment server, cluster manager and everything. But what I did here, so just to go back now to what we have, just wanted to point that out. So we have, so if I go back there, so you see the screen now, right?
Yes.
Okay, so what I went to that, the base configs there, and just from the knowledge of understanding how they are set up, so I know this would be an indexer cluster. So, I had to add the rep factor, this, that, so it should be auto, and also set the volume. So I set that, and then now I have custom indexes. So all my default indexes will still go to valid Splunk. Remember, if I wanted to change that permanently, where do I go? We talked about this over and over. Where do I go and edit to change it permanent?
SplunkLaunch.com.
Yes, SplunkLaunch.com. So I go there and change it. But again, what Splunk wants is they don't want you to, because SplunkLaunch.com is not accessible by the cluster manager. Cluster manager deploys configuration to where? Do we remember when configurations are deployed from the cluster manager, where do they go?
Server.com.
Index.
Sorry? What location does the configurations go? So when we want to deploy the configurations, we go to etc manager apps, right? And then create them there. And then we will push them, we'll push the bundle to the indexers. Where do we go look for those configurations on the indexers?
Input.com.
So what you're calling is a configuration file. I'm asking for the location where you can find the configuration file.
You're gonna be on the app,
No, so that's the difference.
master apps.
No.
Okay.
So let's come back here. I had that, okay. So here, if we go all the way down to here, so when we are creating configurations on the cluster manager, we go to etc master apps or manager apps, either in underscore a cluster, or we create our own apps, right? But we put it here. When we push it, we have to go to the indexers, etc either slave apps or peer apps. So that's where we look for them, slave apps or peer apps. So when the configurations are deployed, they don't go to apps. That's the difference. That's the great difference from the cluster manager managing configurations versus the deployment server. The deployment server sends it to etc apps. Even when we go to sachet clustering, the deployer also sends the configurations to etc apps. But the cluster manager is different. They want to package. So that's why it's a bundle, because everything is identical. It just sends it to the slave apps or peer apps. So that's what we are saying here. So all this configuration now, these indexes are sent to that, but we know that the default indexes are not we did not set any locations, so we're still using the default location for our default indexes. So we are going to copy this now. I hope, is this clear? Do we have any questions on the explanation here on our indexes.conf? So I'm going to copy that whole thing. So I'm saying this is a cluster, so replicate the indexes, but that is the location I want them. So copy that. If I go to my in there now, my indexes.conf that I created. So we have that's the location and everything. Save it. Okay, and then we can just cut. Are you guys seeing my screen?
Yes.
Yes.
Okay, this thing is just moving around here. So cut. Indexes.conf, and we see settings we set there. Okay, so they're there. So we have inside of local now, if I LL there, we have these three configuration files, indexes.conf, input.conf, and web.conf. So we want that to be identical on all the indexes. We're going to now deploy this on the indexes. So we could run a CLI command to do that, but you guys know me now. If I have the access to the browser to do it, I know I can do it there, I would use it. So on here, we see everything is green and looks good. We can then manage and deploy configurations from here. One of the difference again between the cluster manager and the deployment server, the deployment server, as long as the clients are connected, when the server classes, everything is set, they would pull the configurations. They will come and look for the configurations. Always, they do that phone interval and download the configurations. On here, that does not happen. You have to manually deploy it. So you would create the bundle and deploy them yourself. So they would not be automatically deployed. So that's why to deploy the bundle, you go there, you see edit, and then you have different functions that you can do here. We saw already the manager node configurations. It shows you what specs you created there. You see data balance, like you want to rebalance the data. Remember when we talked about how the cluster manager can, when maybe an indexer leaves and then it joins back again, maybe it took maybe a day or two, we have more data on the existing indexers, we have this other indexer rejoin, we can rebalance, make sure that the indexers have, almost equal amount of data existing in them. We can rebalance that. We can do a rolling restart, meaning initiate a restart here for all the indexers to, restart. We don't have to go manually and execute a restart command on each of them. We can disable clustering and all of that. But what we want to do right now is configuration bundle management. So because I have created something under my etc manager apps, it would right away identify that. So you see here, update the time that is identified an active bundle, says that's the bundle, the ID of the bundle and everything. So I need to now first I'll validate if the bundle is if I didn't make any errors, if everything is good to push. So I'll validate if it's good, if also there is restart needed on the indexer. So if I select that and validate and check restart, it will go through and check the indexers, all of them. You see, it says last validate and check, restart successful, restart required. So these configurations that I will be pushing require the indexers to restart. So that's why some configurations do not require that. So you want to always check that. So sometimes you can do some bundles during production environment, sorry, like during work hours, because they will not require a restart. We'll always check it. So now I see this is good. It says green. If anything was not good, it will not be successful. It says unsuccessful or that. So I can push the bundle now. Push that bundle. So that is pushing right now. It would go through, it would do them one at a time. So this is good again here because it would still allow the other indexers to be searchable. So the data, whatever that exists on the other indexers will be searchable. You would do it one at a time. We'll restart this indexer. When this is complete, it goes to the other one. So that's why it is a rolling restart. You will do them one at a time, or if we have maybe 50 indexers, you do it by percentage, maybe 10% of the indexers first, and then, goes that way. Just to make sure that it keeps your environment still active and you can start. Remember, one of the benefits of indexer clustering is to have data availability at any time. So even when you're restarting, you should still be able to search the data. So that's what we're doing here. And so you see right now we are doing this via the web. If we're doing it via command line, we would run this command. So on CLI validate the bundle. So we'll say opt Splunk, validate cluster bundle. So it will tell you if it's successful or not. Validate and check restart. Again, it will tell you if you need to restart or not. Show bundle status. And then you can now apply bundle. So apply bundle is the same as pushing the bundles, clicking that button to push it. See, apply cluster bundle would ask you questions, you say yes or not. And after that, you can show the status. So you can do all of this via the command line on the cluster manager. But if you can do it via the web, why do you need to go and guess there? Yes, Mr. Clark.
Yes, I do. Does
Yeah.
Splunk recognize this as like normal maintenance and doesn't do a failover when you're pushing applications, or does it do a failover?
So because the cluster manager is managing it, it does not see it as a fail, as the index as failing. So that's why
Okay.
it would do it one at a time, right? It would
Okay.
make sure, because remember the data is replicated. So data on this indexer does not live only there. So it would do this one indexer and make sure there are other surviving ones that could respond to searches. So what it would do first is if there are any origin buckets, right, that are on this index, it would first instruct whatever indexer that has the what we call the backup to promote that into the origin now, or the primary, before this one restarts. And it does that when this one is ready again, promote. So it would make sure that the data is available.
Okay. So it does
restarting
exactly
it.
what it would have done if an indexer was failing.
Yes.
Okay.
Yep.
All right.
Okay, so now go back to my cluster status there. So that's good. So now we did log into one of our indexers, right? So this is our cluster manager. This is our indexers, one of them. So now we said when we deploy stuff, they should go to etc slave apps. So either etc slave or peer apps. So if we go to cd to opt Splunk, etc, we'll check peer apps things. Let's see. The apps, yep. if we check there, LL, you should see the underscore cluster there. So LL underscore, and then local, because that's where we have them. So look at it. So all the configurations that we deployed are there. All the configurations that we deployed. So you see them there. And to even validate that what we did, the instructions that we give that the indexes should be created in, you know, a different location, we can validate that. So we said that our new index location is OPT Splunk data, right? So if I cd to OPT Splunk data here, LL here, you see the two indexes. So they were created here. You don't see the other indexes because those are still in the default location. We didn't set a different location for those. But if I then even LL into the Linux index, so you see inside of there, remember we set the cold database and the DB. So DB, that's where the hot and warm bucket goes, and this is where the cold bucket goes. And if I again now LL into DB, so you see inside of there, it shows that this is the creation time. I mean, the buckets are there right now. It's just the default buckets that are there. We have not sent any data. Remember, there is no data right now. It just tells you that this was created at this time and then all of that, and some metadata. So we can now send data to this machine for it to see. So now again, if we go to our search head and do index equals internal, we should see the forwarder now, because we told the indexer right there, forwarder, we have now told the indexers to listen, right? To listen for data on 9997. So we see that now that is coming. So there's another person, yeah. Clark also has his forwarder here. So now we have to just go send some data. So we want to see how the data comes in, how replication happens, and all of that. Any questions so far? Okay, so we will just go to the forwarder, and so to our forwarder, did we log in there? Okay, that's the other indexer. So our forwarder. So what I'll do first is inside of here, we created so I downloaded the Splunk the Splunk TA for the Unix and Linux. We know that TA already. If I do LL Splunk underscore TA next, so you see, oh, the thing is LL is not available on the local computer, so it's LS. So inside of that TA, these are the subdirectories and files we have there: version, app server, default, you know, all that metadata, everything. So what I want to do is just send this TA into my forwarder and just go grab some data quick and send it to my indexer so that we see how the data replicates and all of that. So that's what we want to do. And we know to transfer this file, what there is a protocol that we use. Do we remember the protocol?
SCP.
SCP, right? So we use the SCP. So SCP. So SCP, because it's a directory, we say -r and then bring so -i for the PEM key, desktop PEM, and then the file that we want to push, right? Splunk underscore, and then the user. So EC2-user, the IP address. So let's check our forwarder. Okay, And then we want to put that in our temp directory, right? TMP. Okay, so let's see if that would work. C2. Yes. Okay, so it's sending all those files, sending them to our temp directory right now. Okay, so that's there. So now we can SSH. Okay. So inside of our forwarder, if I cd to TMP, we see our Splunk TNX in there. So now I can move this to my Etsy apps. So to be able to then edit it. So I can say sudo mv Splunk TNX to Etsy apps. Okay, so moving that. So it's not here anymore. So now I have to just churn the directory again, right? Because so if I come here to my, just to copy that, instead of having to do it again, I can churn Splunk forwarder, copy the whole of it. Okay. And then now I can sudo to my Splunk user. Okay, and then cd to so I have the Splunk TNX there. I can cd to that Splunk. Okay, we have all of this here. We know inside of default, that's where we have our input.com that we want to edit. So what we want to copy to local, we don't have local directory right now. So I'll just create the local. Create the local directory and now just copy. So CP, copy the in default, copy the inputs, input.com to local. Okay, cd to local now. So I have input.conf in there. I'll just vi into that now. And now it's just to enable some of these inputs here. So change that to 0, and then so index equals Linux index. Enable some of them. Just randomly enable some. Okay, var log, I need that. Okay, that should be enough. All right, I need to just restart my forwarder now. Okay, that is sending data. You would restart now and send some data for me. So inside of indexes here, so you see we have Linux index is one of the index. So it shows you inside of the indexes here. It says fully searchable, yes. Searchable data copy. You see, we have one. This one right now is not full because the data is not there yet. Replicated data copies, 2. How many total buckets are there? In each of these index, it shows you that, and cumulative raw data, just that. So, and now we have data in our Linux index. So you see that it is replicated, that's true. So if I go to my search it now and search my Linux index, so right there, so you see data is coming, and if I check my forwarder, is that forwarder that we set. See that there, and then all the sources, source types, so data is coming in. So that's good. You see data coming in. Any questions there?
Yes, I have a question. When you were enabling those files, you said it can be randomly. Does it has a number that if you don't enable up to that number, it will not, the functionality will not perform perfectly? Or, and also you were searching for varlog. Assuming one enabled, then it doesn't include varlog, will they perform erroneously? That is, the performance will not be what you expected.
So the monitoring there would not relate to any performance. What I was saying that I'm doing a random is, right now I am not trying to do any use case. I'm just enabling because I mean, we're short in time. I'm just going through and enabling anything. If you are tasked with onboarding data, you would be given specifics on, okay, go bring in whatever statistics of processes that are running. I need to see logs in my secure log. You know, they will tell you the specifics. So it's not, when you're enabling it, it's not a random thing that you would do. I was just saying I'm doing it randomly because I mean, I just want data. I just want to you guys to see that data is being monitored and sent to the indexers. That's what I want to prove right now. I don't have a request where they're telling me to do a specific, you go monitor a specific directory or run a specific script that would collect data and send it. Just know that the app that NixTA has all the inputs in there. Just what you need is what you enabled. So what I was saying is I'm just enabling them, I mean, with no specific intention. It's just enabling just for me to get the data.
Got it. Thank you.
Yep. Okay, so we see data is coming in. So now if we go to the indexers, if I go, so this is my indexer 1, so we were here, right? So we were inside of DB. So at the first, when we ran this, we just see creation time and all. Now we should see some data. So look at that. Now you see data inside of that index. And you see, so it has the hot bucket. And then, so we have 2 hot buckets right now. So let's just see here how data is viewed in Splunk, right? So managing, so this is the same, this is the same information about, you know, the indexer clustering. So it's just another topic in it. So how the indexes, how data is stored in the indexes, we know inside of the indexes, we have the buckets, the hot, warm, cold, frozen, thawed, all we explained the meaning of them, how, you know, they store the data and everything, and the locations, the default locations, right? And you can change it. We've seen that now. Bucket naming convention, the state of the bucket, hot or warm or cold, all of that, clustered and non-clustered. What I wanted you to see is this. So the names, how the naming convention happens. If it is a non-clustered bucket, we have the hot bucket. When the data comes into Splunk the first time, they go into the hot bucket. And then after that, it would then roll over to warm and then cold and all of that. So if it's a non-clustered environment, and that's what we've been doing, which is just individual indexers, the naming convention will be hot v1, and then the local ID. So local ID will be either 0, 1, or that. And the other buckets, which are the warm, cold, third buckets, they will be named this way. DB, the most recent time. So they will be given a timestamp. So when the time where the most recent data, the data that comes into the bucket, that most recent time and the oldest time. So it will show you in between. So this bucket has data from 5 a.m. to 2 p.m. today, this date. So that's why when you're searching in Splunk, that's why they say time is the most relevant filter. When you specify the time, it looks for that exact time and gives you the data. So you see it says DB, most recent time and the oldest time, and then the local ID. So again, if the ID was 0 or 1, it will show you that. For clustered environment, the origin, so you see hot bucket will still be hot v1, the local ID, if they're the hot bucket, and that's what we see here. So hot buckets, the hot bucket will be this, you see, hot v1, and then the local ID, and then the warm buckets now. So warm buckets now would be, so the hot buckets, they are not the data in the hot buckets is the most recent. You can see that it is not being replicated yet. So it's when it goes to when it rolls over, that's when the replication happens. When it rolls over from hot to warm, everything in the bucket is when after the rollover happens, that's when whatever is added to the buckets, that's when they are added. So the newest data goes to the hot bucket, and then like I said, if it's clustered, you have that, and then if it's hot bucket, is that, I mean, if it's cold bucket, it has that naming convention. And so that's what we're seeing here. Hot bucket, hot v1, the ID right now is 0. And then the it's just showing you the multiples of the buckets. So it shows you right now, this bucket is local ID 0, and the GUID, remember we said each indexer has a GUID, right? And the GUID is what represents that this is where that data is coming from. So when this data is replicated to any other indexer, it would say, you would know that the origin of this bucket is indexer 1 or whatever, which is replicated by the GUID. So you can see here we have different GUIDs of the data. So the data is replicated now from one indexer to another. You can see that. So that's why it shows this is still hot, but it says there the GUID and the local ID, and then the GUID of the indexer, again, local ID, the GUID of the indexer. So that's what we have there. Right now, we don't have too much data. So all this is hot data, hot buckets. We have different ways of forcing a rollover to happen. Either for the bucket, the hot bucket to be full, meaning if you set it to be 10 gigs, when that number is reached, it would roll over to then cold or warm. It will roll over to warm and then cold and whatever. Or if there is a time limit, it says for 24 hours rollover. Those are the first two cases. The other one is when a restart happens. Even if the two criteria are not met, when you restart the indexer, the buckets roll over, all hot buckets roll over. So we're going to force a rollover right now. I just want to show you how how it shows the warm buckets and how the replicated buckets show. Right now, you don't see that RB because they have not been replicated. They're all hot. So let's force a rollover. And to force that, we'll just come and do a rolling restart. So rolling restart will restart all the indexers, and then that would force the buckets to roll over. So let's do that. And I don't say do this on your production environment. I'm just trying to show you what would happen right now. So you would not go and do a rolling restart for no reason. You don't want to force a rolling of your buckets, but I just want you to see how the difference right now. So we see what we see here right now, and you see the naming convention, right? Non-clustered. It's easy, just has hot local ID. If it's a warm, it says DB in front of it, the newest time, oldest time, and local ID. If it's clustered now, hot, again, and local ID, because the hot is not replicated, so it does not need to have the GUID on it. Now, the warm, cold, and the third, you see it says DB, newest time, oldest time, local ID, and the GUID. Remember, the GUID is the identifier for the indexer where that data is originating from. So that when it's replicated, it's easy to see. So you see now, clustered replicated now, when the buckets are replicated. So cluster again. So when okay, so when the buckets are replicated in the cluster, if they're hot, is the GUID, sorry, is the local ID, it does not say hot. Okay, so that I take back the word there. So in this case, it's here. This even makes it even better now to explain. So hot bucket, this is the hot bucket that originates here. This data hits here. That's why we say hot v1 local ID, right? This now here, so just to show you, let's go to the indexer cluster here, to the peers. So the GUID, to see this this first one, let's try to identify what is this, which one is that GUID? 6CA, so that's that one. And then 3062. Okay. And then this, so this indexer, this that we are on right now, is the second one. This is the indexer that we logged on right now. So this is the indexer that we logged on. The bucket that originates on this indexer would appear this way: hot v1, and then the local ID. The local ID will start from 0 and you would continue now 0, 1, 2, and all of that. So this is the bucket that originates here, and this bucket now will be replicated to the other indexers. I will show you that it would go appear as the ID and then the GUID of this indexer, which is this GUID. So that's why when you see here right now, you see it says 0 GUID of my other indexer, because this data is a hot data, but it was replicated from another indexer. So the ID and then the GUID. And then you see that this other indexer has 2 buckets. So it has 0 and 1. So you see, so 2 buckets are replicated from this second indexer, this one. So it are replicated to here. So let's see, is this another indexer that I logged into? Was this the, this is my forwarder, right? Just wanted to make sure. Okay, this is an index as well. So okay, so this is the second indexer. So if we cd to, again, OPT, OPT, we know in OPT we have Splunk data, and then inside of that we have Linux index, and then Linux index we have DB, right? Inside of DB, LL here, you see the replication going up now as the data is coming, is being replicated. So let's look for, oh, right here, you see a restart has happened. So even if here now, if I do LL again, so restart has happened. It has forced the rollover to happen. But let's compare the two buckets, the two indexers. So this, we say this indexer is this one, right? This is this indexer. And then this indexer, hot bucket, so this is this one. And this other one, so meaning DE2, 26DE.
Are we
Okay.
seeing, I have a question, please. Are we seeing multiple GUI numbers because the system restarted? The GUI that
What do you mean?
So the part that has the DB and the RB.
Okay, so that's where I'm coming to. So here we were seeing when we started here, it was just the hot bucket. They did not roll over yet, right? In the naming convention, we said when the bucket is hot, right? In the clusters, it has it says hot V and then local ID, right? If it's now warm, cold, or it has to roll over for it to be warm, cold, or thawed, right? It will roll over from hot to warm. So for it to roll over, we force the restart. So that's why before the rollover, we were just seeing either a hot bucket with a local ID or a replicated hot bucket that has the local ID and the GUID of the indexer. So that's what I was seeing here. So you see the hot bucket, because it's generated here, this is a replicated hot bucket from this indexer, which is, if we go to the indexer cluster, that is 68CA. 68CA, it was replicated from this and the local ID. And then the same, this is the other indexer, it was replicated. So this is hot. When we force the restart, now we see the same buckets that were replicated, right? The indexers, the hot bucket are still there, but now the buckets roll over. So we have a rollover now from, if you look at it now here, from the hot to warm. So, and the naming convention for warm, we have DB in front of it, newest time, oldest time, the local ID, and then the GUID. So that's what you're seeing here. So it says DB, newest time, this is just the epoch time. So you can convert this to see the actual human readable time. This is epoch, is Linux time. Newest time, oldest time, the ID, local ID, this is 1, GUID of the indexer. So it's saying that this bucket came from this indexer, which is this 63062. I don't know, is this making sense? 3062, it came from this indexer.
Yeah, so I think when we see the, I don't know if this is correct. So when we see the RB, does that mean the cluster has been replicated?
Yeah, so RB is for buckets, warm buckets that are replicated.
Okay.
So warm buckets that are replicated would have RB in front of them. So here, the warm buckets that are replicated would have this. This is just the buckets, the DB it shows that this is the bucket, it lives here. This is 6.2. This is the indexer, right? We said this indexer is what we are on. This is this indexer. We've identified that already, that this is the indexer we are on. So that's that. So because these are warm buckets now, it would show you DB, the old time, recent time, local ID, and then the GUID of the indexer that it is on. When it is replicated, now this is showing that it came from another indexer. That's why it says RB, but it is a warm bucket. It's not hot anymore. That's why we have the RB, again, the time, which is the oldest and recent, local ID, and the GUID of the indexer. So because it's replicated, we know it has to be another indexer. It cannot be the GUID of the indexer we are on. So you see here, you would see the other GUID. So you see this one and the other one, the other two indexers. So this 26DE, 26DE, and 68CA is this. So this indexer is the one we're looking at right now, meaning these buckets are the ones, the original warm buckets in that indexer, and this is how they are named. The replicated bucket from the other indexers are these, the other two indexers, so they're here. The hot bucket on this indexer is this one. The hot bucket on this indexer, you have the hot because it originates here, V1, and then whatever the local ID is. And then these are now replicated hot buckets. So replicated buckets, again, you would see that you will not see the GUID. See this GUID? You will not see it among these buckets because these are replicated hot buckets, the newest data. So they came from the other two indexers. We know the naming convention of the replicated bucket is the local ID and the GUID. So look at it this way. For hot buckets, the naming convention is if the origin, if the bucket originated from the indexer itself, it would start with hot, V1, and then the local ID. So if you see that, no, that bucket originated there, and that is a hot bucket. If it's a bucket that is replicated from another indexer, it would say the local ID of that bucket on that indexer, and then the GUID of the indexer, meaning this bucket came from another indexer. If the bucket is either a warm bucket, a cold bucket, or a thawed bucket, you would have these other naming conventions. So if the bucket originated from the indexer we are on, you would say DB, the time, the local ID, the GUID of the indexer we are on, and that, so that when this bucket will be replicated, you would have that GUI. If this bucket was replicated from another indexer, would have RB in front of it. RB and all the other things now, the GUID of the indexer I came from. So that's what we're seeing here. So hot buckets, origin, replicated hot buckets. Warm buckets, origin, replicated warm buckets. Make sense now?
Yes, it does. Thank you.
Yep, so that's what we're seeing here. So this is good to really know how to identify this. So if this was not an indexer cluster, all we would see is just DB. Okay, just see if we look at it here, if it's not a cluster, so it's a non-clustered. Hot bucket would have this local ID. So you say V1 local ID 1 or 2 or 3, and then the warm bucket would be DB again, hot, the recent time and the oldest time, and local ID. It would not need the GUID there because this bucket does not need to be replicated. So you just see all the buckets in the indexer if it's not a cluster, meaning they originated there, that's why they are there. They didn't come from another indexer, so they don't need any identifier. But as soon as you enable a cluster, then we start adding the identifier, the GUID there. So that's what we're seeing. So clustered, I mean, this you'd have to read a little bit, but I wanted to, this is one of the biggest to understand the bucket structure and how, because let's say if you were moving this data, like sometimes you'd have to, I've seen cases where you're migrating from a non-clustered indexers to a clustered. So imagine when you, the data that will be on the indexer that is non-clustered would not have a GUID representation. So if you want the data that was in the indexer before it joined the cluster to be replicated, you have to manually add because when you make the indexer join the cluster, it it would be given a GUID. You would have to manually on all the buckets add that GUID, and then it will be replicated. If it does not have, it would not be replicated. So that is a manual process. You have to understand that. But understanding the breakdown of the data, you understand which data was originated here, which one is replicated, that is really, really paramount. And how the data rolls over. I know it's gone a little bit out of, there's a lot more we can talk about with clusters and all of that. I think Monday lab would be again very relevant. So I would say come Monday, we would continue into this. So Monday, what I want to do is give you guys to go maybe have a cluster. So first of all, have a cluster. So you build a cluster, try to build it yourself. Sorry, no, build an indexer, 3 indexers that are not in a cluster, connect the searcher to them and all of that, and then send data to those, to the indexers. And now we want to then migrate from that non-cluster to a cluster. So we will do that on Monday and see how we can migrate the indexers and also migrate the data. So you can migrate the indexers and the data and make sure your data is living outside of your Splunk Splunk application. So create a new folder or a mount point or whatever you call it. Create a new volume where you're gonna put the data so that it does not, you're not prone to whatever problem happens to Splunk, you lose your data. And then we'll see how we can migrate into an indexer cluster, how we can migrate the data. And we were supposed to also force a failure and see how the indexers would respond to that. But I mean, I think the question that Lionel even asked on when the indexers are restarting, that is a temporal failure, you can say, because when an indexer is restarting, it is not participating in any searching and anything at that moment. So the indexer cluster has to survive without that indexer until it comes back. So if the cluster manager is able to manage the affairs of the surviving indexers until the indexer come back, that is being able to survive a failure. But we would actually shut down an indexer for an extended time, just go and stop it, just assume that it crashed, and then see what would happen. We would have error messages, how the bucket will be, promoted and all of that. So like I said again, the cases where you would be asked to build a cluster from scratch, like a company employs you and then say, come and implement an indexer cluster for us, is limited. Most cases is you have a cluster already in your environment and you are managing it. So knowing how buckets are represented when they are, clustered or not, how they replicate, knowing how to balance. So for example, in here now, when as you see the cluster dashboard here, when we go to indexes, it shows you the indexes that has data. And you see Linux index is one of them. It says one copy is searchable, 2 are replicated. If we go to bucket status, right? This is right now at the index level. If I go to bucket status, it takes me into, right now I don't have any problems because I have not shut down or done anything bad. So it will show you, like I told you, the cluster manager will initiate fix up tasks. So if there was any time when an indexer goes down, and it is trying to promote buckets and all of that, it will try to fix up the buckets and try to, assign, promote whatever secondary to a primary. It will show you how many tasks are currently being fixed up. It shows you pending fix up tasks. It shows the indexes with excess buckets. So remember when we said when we simulated the scenario where the 2 indexers dropped out and then joined back the cluster, And because of that, we had excess buckets. So if you come to this tab, you would see all the indexes that has excess buckets, because right now we have not simulated anything. So the bucket you see, it says 000, but you have the option to remove all excess buckets or do it by index if there was any excess bucket. Remember, any excess bucket would just be occupying storage space in your environment. So you can come here and fix that total excess bucket count, all of that. You can see whatever fix up, if there are, it will show you errors here, whatever reason why the fix up is happening, time before the fix up ends, current status, all of that. So these are the tasks or the things that you will be required to manage, understand how the data is being replicated, how it is managed, where the data lives, what is the good status for the data, why is data not being replicated, if it's being read correctly. All of that is what you do day to day as a Splunk admin, rather than building the cluster. So I would advise you, study, managing the data more, because that's what you would face. So we would go into this more and more on Monday. So that's why Monday class will be really relevant. So come migrate from a non-cluster to a cluster, try to migrate the data as well. I wanted to say we will even try maybe upgrading and a Splunk. We've not seen how we can upgrade Splunk. I wanted to get to index a cluster and show you, like, you have a format, you have the machines that you should start migrating and upgrading. It's a lot of things we can cover. Some of these topics will be bonus topics that we will do, like migrating from one Splunk physical server to another and upgrading. We will do that. Maybe next week we'll just learn how to manage the data. Monday, how to move from a non-cluster to a cluster, how to migrate the data to that cluster, and then make sure everything is working fine. The data is searchable. If there are any errors, we do the fix up. And then because I want next week, Tuesday, for us to start front end, for us to start doing the searches, because we have limited, weeks left now for the class. I want to cover the important things. Like I said, we would have additional, bonus classes, and it would be, if you want to join, you can join and just learn. If you don't want to, you feel comfortable now with what you know, again, it's on you. But yeah, I feel like we've gone way above time. Any questions before we stop for today?
I have a question, but this is just out of curiosity. When you say upgrading Splunk, do you mean the version?
Yes.
Okay.
Yep, upgrading the version from one to another. We are having new versions of Splunk every now and then. And you can even learn how to do patching. So upgrading, not Splunk, but the operating system or the machine that Splunk lives on. So, because of security, there is always, so the way the world work is, we have these bad actors. They are always finding ways to, just infiltrate like valuable information. So when and companies, so they have we have in security, we have the red team and the blue team. The red team are the attackers, the ones that try to infiltrate, and the blue team are the defense. So organizations try to always simulate this, try to simulate themselves. What vulnerabilities do we have? How do we fight against that? So they have inside of the red team, blue team, they will simulate attacks and try to fight against them. That's what the bad actors will do. They try to always see what weaknesses you have and try to, take advantage of those. So because of that, these application owners, Splunk, one of them, they would see, as they feel like a code or something, some bad actor is identifying how to break a code and get access to, something valuable. they would do an upgrade. They would do a patch upgrade to fix that security vulnerability. So that's why you are expected to be upgrading your Splunk environment, because if you don't, you'll be exposed. They will tell you there is a security exposure for these versions. You need to upgrade to this. Recently, we did that in our environment because there was some issues that were identified. So, and when that new version comes, the bad actors will study that again and try to see if they can identify. Before they can identify vulnerabilities, the software owners would again patch it, and that's how always the cycle is going. So you should keep up, trying to always match up with the upgrades and all of that. And that goes for both the operating system, meaning the maybe Linux operating system or Windows or whatever operating system where Splunk is living, and the Splunk application itself. So that's why when we say upgrade, we have the OS upgrade, which we normally call patching, and the Splunk version upgrade. So they are different, but we can learn how to do all of them here.
Okay, thank you.
Yep. All right, any other questions? All right, stop the sharing. Stop the recording.